amongst our social networks and health scholars and amongst others, my students about, how do you deal with many networks when what you really want to do is one of these already complicated analysis routines like a Siena model. And so thankfully, Daniel Reagan, who has spent probably more time dealing with this kind of problem than anyone else I know, as part of his work on a team that I'm lucky to be part of, with which is the Prosper Peers Project, where we have, what is it, 368 distinct network instances or something like this, that are all dynamic networks that are linked together across high schools and junior highs. And so it's a really rich area to study Siena kind of models, but it's also really complicated. And so just really great to have you here, Dan. So thank you. So the general gig is give a quick update. We don't have as many I know we lost some folks here all of a sudden, but go ahead and just just do a quick update and tell us what you're thinking, and then we'll just move over to questions. So.
Yeah, thanks, Jim. So like Jim mentioned, I'm have been working with the Prosper Peers data now since I was a graduate student, really. And for those of you who aren't familiar with that data set, these are data that were collected from students in 28 communities with 2 cohorts in each community in rural and semi-rural school districts in Iowa and Pennsylvania. Data collection occurred through 12th grade. Jim mentioned that there's over these 370 networks because he thinks about it a little bit differently than me. I spend so much time on the longitudinal aspect that for me, I'm thinking about it as over 50 distinct networks, each cohort within a school as being its own network. And this really presents both a challenge and an opportunity, because if you look at a lot of the network methods that we have, they assume that you're working with either a complete population or a semi-complete population. And oftentimes when you then estimate the model and you get the results, you're saying like, okay, this is my estimate that applies to this population. Well, in our case, when I'm looking at longitudinal models, I have over 50 of these types of networks. And so the challenge is, okay, how do you present these results? Because the truth is nobody really wants to look at 50 estimates for each parameter. You could imagine someone doing that, just saying like, okay, like I ran a different model or the same model on every network and here's what the results look like. Meta-analysis is one way that you can aggregate results. This particular form of meta-analysis isn't the only way, but it's one that we've kind of settled on as being a really useful way. One of the things that I mentioned in the lecture video and that I could probably make a bigger deal of is that we use this approach for these Siena models, but there's really no reason that you can't use them on other network models as well. And so, for example, if you're just looking at the very beginning of the study, before there was an intervention, and you're just looking and you're saying, okay, it's cross-sectional, we're going to use the exponential random graph models, you could also use this type of approach as a way to aggregate those results. Let's see. I guess the only other thing that I want to add is that this has been a really useful experience to get me to think through some of these models. And because of time purposes, just in terms of putting this together, and for those of you who were on the call before I started talking, I mentioned that I now have a 3-month-old roommate who doesn't let me get as much work done as I'd like. I had all these topics that I'd really like to add on if I was given the opportunity to do this in the future. And so I'll just mention 2 of them. Probably the biggest thing that I'd like to talk more about in the future is about the variability and the variance that you get out of these models. Oftentimes, if we look at a set of results from network models, they're never going to be exactly the same. And there's this question about, okay, are these differences real? Are they true? Are they meaningful? And these variance known meta-analyses give you an opportunity to essentially look at how much the standard errors are overlapping with one another. And so if you have 2 estimates that are different, but they have confidence intervals that are overlapping, is going to be a sign that, hey, maybe they're coming from the same population. Whereas if they're really far apart and the confidence intervals don't overlap, that's not going to be the case. The other thing that I'm interested in doing, this is kind of like a miscellaneous thing, is on my slide, I mentioned that there are a lot of different software packages that you use for these types of models. And I usually use the HLM software package, and that's just because I was trained in multi-level modeling and using that package, and so it's easy for me to use. I have used the R metaphor package before, and I wrote the script using that package, assuming that because it was free and you guys would be using it in these workshops, that it would be best. Um, but I'd like to dig in a little more to the difference in the packages, because HLM, besides the fact that it's point and click, is now a subscription-based software. And as much as I don't mind paying a lot of money for a software package every couple of years, I really hate paying every single year for something that, in my case, is only used for one purpose. And so one of the things that I have kind of a note on my to-do list is to really dig into the statistical models in those packages and see how they're different. In most cases, I'm assuming that the results will be very comparable, but that doesn't mean that that's always the case. And so in the future, I'd like to be able to talk a little more about why that is or isn't the case. All right. So I guess at this point, I ask if there are any questions.
Just to open it up for general questions. I can pepper you with a bunch of them if you're interested, but I know that people might have specific analysis issues in mind. Maybe back up just a second. And what's in your experience, having worked with a lot of these things, what's the most, what are the bottlenecks? What are the places that when it, the actual, the practical crap, I wish I'd done this differently sort of moments, that if you were to start over again with the Prosper data and you were handed all these 50 different school sequences, that you would do differently?
Do you mean for the meta-analysis or for
Yeah,
the Siena type analyses?
for the whole pipeline, so getting from the Siena analysis to the pipeline to the final meta-analysis, all that kind of thing. Yeah, so how do you set it up?
How do you set it up? I don't know that I have a great answer for that. I would say the one thing that I've learned in order to avoid bottlenecks is that because we have so many networks, and because some of these networks are quite large, including several hundred students, followed over 7 or 8 time points, and the Siena models take so long to estimate, and then you have to, when you're done, use this. I use a lot of kind of toy code to test things out a lot. And probably one of the biggest things I've learned is that if you try to do everything at once, you'll find that you made one little error and it will stop everything. And so if you're dealing with this type of thing, and by this type of thing, I mean these many networks of this size, where you're going from maybe descriptive statistics in your software package of choice to running models in Siena, and then you're trying to aggregate them in something like HLM. Learning how to do bits and pieces and making sure that you check your code really thoroughly before you start looping it. And here's where it's I can say oh yes, I always do that and I'm great at that. But I can't tell you, for example, how many times we've spent an entire week waiting for models to be estimated on the cluster computers, and then we get the results, and oh, guess what? I left out a comma or something. And the results are not really usable, and I have to start all over. This is the point where, if anybody is kind of had this happen, you probably realize that I'm talking about yeah, that's part of being a graduate student. And if you talk
it's part of being an analyst, right?
To Jim or my advisor in graduate school, they'd be like, that's why I have graduate students.
There's a question in the chat about using the structural zero approach and why it's recommended or not recommended.
Yeah, it's really not recommended. The way that the structural zero approach is, actually, sorry, let me back up so it makes a little more sense. Whenever you estimate a model in Siena, Siena is going to require a different file for each of the covariates. And I don't know if those people have seen David Schaefer's talk yet, but he walks you through this and he reads in these files. So for example, let's say you had just a really small network for a school at least, let's say you had 100 people. And so you would have a file that has a 100 by 100 matrix so that you know who their friends are. You would have a file with 100 people, and then for every line you'd have their values on covariates, and you would have that for every single network. So if you are going to do the structural zero approach, you need to make one file that has all the networks in it. And if these people can't actually be friends with one another, let's say you have two networks and they're two different states because they're two schools, the way you do that is you include these structural zeros as a way of letting the program know, actually, no, the fact that they're not friends isn't because they didn't nominate each other. It's because they literally cannot. They're not in the same network. Now, if you had two networks, maybe this kind of works, right? But if you're talking about a study like ours, where I have over 50 networks, the structural zero approach, if I wanted it all in one network, would mean that all, let's say, 15,000 people who have ever been in my study are actually represented in the same file. It's extremely tedious. It presents a lot of opportunities to make errors. And beyond that, it really doesn't seem to offer any real advantages over the other approaches. And so that's where you're giving yourself a lot of work, and it doesn't seem like there's much of a payoff. And that's what I believe that Tom Snyders, who's the person behind the Siena software, I think that's his approach right now, from what I understand, is basically that this was an early way to do it. Especially if maybe you had things like small classrooms in preschools and you had small numbers of students. But over the past, I'd say, couple years, he introduced a multi-group method, which pretty much, I think, my understanding is gives the same results. And then people have been exploring with meta-analysis and introducing that as well.
So the question is just thank you, Leslie, for clarifying there. It says one reason I'm asking is that all my covariate data is already in one giant file, and I have one large peer nomination file already. So I really need to know if there's a disadvantage to using the structural zeros, particularly to the kind of estimates you might get out.
Yeah, my understanding is that the estimate should be the same as multi-group, but that it will probably take a very long time. And also that I think it's going to constrain your estimates to be the same across the different groups. So maybe that's something you want, especially if you have small networks and they're kind of drawn from the same general population. And so you want them to be constrained to be the same. And if they're small networks, and you can estimate them and there aren't, it's not causing issues with time, then, I mean, I don't think, one way to say it is, what would I say if I were a reviewer on a paper? And the answer is, well, if it kind of makes sense that they're constrained and they're fairly small and you were able to estimate it, I would say, okay, that's probably the same as a multi-group. So I don't think that it's inherently wrong. I don't think it's probably the way that I would set it up from the beginning.
One reason that I could imagine that it would be, maybe correct me if I'm wrong here, but the reason that I would assume the structural zero approach is particularly useful is when you have, kind of like we have in some of the communities that we're dealing with, where you have multiple elementary schools at time 1 that feed into junior highs at time 2 that feed into high schools at time 3, and that whole system, there's a probability at the end for students to be able to nominate each other, but at the first wave they couldn't, and so you would put structural zeros in the first wave, but not in the end. Is that accurate?
Yeah, I think so. And I would have to look to see if we did that in our files, but yeah, that would make sense to me as another reason to include them.
Yeah, and I know I've heard, and I don't know if I'm not, never mind. I was gonna say I've heard people using it, using structural zeros to essentially coerce a Siena model into a bipartite model. I don't think I think that's an off prescription use of the software. So
yeah.
Other questions that folks have for Dan about how to do this?
John, you asked to walk through the HLM setup. Could you be a little more specific?
You actually already addressed the question. You did a couple of things back, so I'm okay.
Okay.
Thank you.
That folks have you had any just intuitively, do you have an insight into whether essentially we find more cross-level variation in peer influence effects versus selection effects?
I want to say that they're about equal in terms of the selection versus influence. But one thing is that the current setup of Siena, there used to be something that allowed you to kind of test that a little bit. I don't know that maybe tested is the right word because it wasn't a formal test, and it, obviously you're dealing with different kind of metrics and different types of systems. And so you're kind of talking about the effect sizes, I guess. In that sense, yeah, I'd have to go back and revisit, especially with some of that.
Yeah, I mean, I know one of the things that you would assume that, one of the things that just intuitively it's always been like a little annoying for sociologists is that oftentimes the setting level effects are smaller than you would hope they are. That all the action is within as opposed to between, and so one of the things that we have discovered with the Prosper projects is that that's not really the case with a lot of these network models. So there's a lot of room for the intervention effects, for example, that we've discovered, which are school level effects that are the people weren't finding originally in the 80s and 90s when they first started doing neighborhood effects models with meta-analysis and HLM. So there really is an opportunity to see the ways in which these network patterns differ, which is kind of exciting.
Yeah, so we have, I don't know if Jim's mentioned this, but there's going to be a book coming out that summarizes some of the main Proctor findings and looks at extending some of them. And for one of the chapters that I'm working on with Cassie, who's also going to be, I think, presenting later today, if the schedule's right. That's one of the things that we're going to be talking about and looking at. I've done some of that work already. I guess one of the things I can mention about that is that it often depends on what your outcome is and kind of what variables you're looking at. And by that, I mean, if you look at the amount of variation that we have on some of our covariates, there's a ton of variation across these different networks. And on some of these covariates, there's very little. I know I was looking at initiation into drinking and selection and influence, and I was looking at kind of these network-wide predictors. And I just had really large standard errors. And one of the reviewers on the paper asked, why are the standard errors so large? And I dug into it. And it was basically that if you look at these networks and you look at them in 6th grade and you start asking about behaviors and beliefs related to drinking behavior, you don't really have too much variation at that point. And so I had all this great theory about it, and I just didn't have the data to really explore it. And then for some other measures, we do have great variation, especially later on as students are moving through middle and high school.
Exactly. Please, Shannon.
Thank you, and congratulations on your new roommate.
Oh, thanks.
So one of the things I'm curious about is I know sometimes we're always looking at how things stick together, but I think what you're talking about too is how when there's outliers and you keep seeing these outliers, and when you're dealing with something like this and you have so much good data, can you ever do sort of a longitudinal multiple n of 1 and then look at how those outliers with this hierarchical data structure, can you do that?
That's an interesting question. I think you could, if you went in and you were to, for example, code the outliers, I mean, and then put that into the model and then trying to understand why they're different or how they're different. I mean, one of the things that's great, especially about using R in the metaphor package, is that it allows all sorts of flexible ways of looking at it. So, if you were to take, for example, the dummy data I took in the outliers and say, okay, I'm going to create another variable and go in knowing that this one is just much larger as a way to account for it or to try to explain why it's different. It should be able to do that. I can't say that I've ever done it myself. And so I don't want to, be too, give too much confidence to that answer, but I can't see why you couldn't.
Thank you.
Do you have an opinion on the on sort of how consistent your model specification has to be across the different settings in a large setting? I'm thinking, for example, like some of the Prosper schools, we have almost no minority students, so fitting a same race coefficient in some schools is sensible, but it's not sensible in the others. and I assume that the other people in the audience have data like this, if that's where you would, the right model in setting I is just going to include different covariates than the right model and model in setting J. And do you have a sense on when it's possible just to treat those as fixed zeros in one case and not in the other, or how would you recommend doing that?
So what we usually do is we do our best to fit the same model to all the networks. And I think that that's, you know, I can actually, as I'm saying that, I can like see Tom Snyder's like shaking his head at me or something, right? That's just a practical aspect of the fact that we have so many networks. One could certainly take an approach where you say, okay, I have n networks and I'm going to fit n models the best that I can. And this is particularly true for things like goodness of fit, right? If you're saying like, I'm going to try to find, you know, the best combination of terms to maximize fit. You know, Jim, you mentioned the same race, where in some networks that's probably really important. And some networks, it's like, well, you know, you just don't have enough students to get derived meaningful estimates. We've taken the approach of really, with few exceptions, trying to make the models as comparable as possible. And we do that because whenever we present our aggregate estimates, we want to say this is the estimate controlling for everything else in all these schools. Now, if you were to, you know, I forget how you said that you would go about, you know, fixing it or whatever, but you can do that. I mean, there's one of the things that's great about the meta-analysis approach is that you don't have to have the same parameters in all the models. And that's something that is different from some of these other approaches like the structural zero approach or the multi-group approach, although there's some flexibility on that. And so you could add and take things out and say, okay, here's going to be the estimate, you know, I have 50 networks. Here's the estimate just from the 40 that have this term, or just from the 20 that have this term. And that's still appropriate. I mean, I'll still estimate it. I think it gets a little bit trickier where you say, well, okay, I'm controlling for all these other things. And now all of a sudden, some of the estimates have a different set of controls. And I think that's really more of a theory thing than a stats thing, because the model will estimate either way. It's just about how you're interpreting it.
Yeah, you definitely don't want to combine a model where I guess intuitively I'm thinking that you want the same substantive model, and so the controlling for a feature that can't exist in the model should be irrelevant. And so my intuition is that's equivalent to fixing that parameter to 0, because it's just not there. But it'd be interesting to think about that. I mean, but you certainly wouldn't want to include the 0 effect in the you know, that fixed 0 in the race variability model at the level 2. So interesting. Sorry, it is fascinating. I think one of the things that those of you who had a chance to watch Bria Perry's Ego Network talk last year is that this notion of an HLM model is the way of dealing with relational effects on ego networks. And the reason it's interesting is that you have essentially these cross-level interactions. And I think that we're so used to thinking about networks as a whole, as this in this case study sense, that being able to think about cross-level interactions and network effects is just really new. So I think we don't have a whole lot of intuition around it. But things like, especially in the school settings, when you can imagine things like whether you have tracking or whether you have a schools in schools model, or whether you have experienced teachers versus not experienced teachers, these are all the ways in which you can think about the ways that settings constrain things like peer effects. And in many ways, what a school health promotion program is trying to do is make peer effects irrelevant. And so, like, if you want to stop kids from influencing each other's smoking behaviors, you have a really strong smoking program at the school level, maybe, or at least you're able to ask the extent to which these things interact with each other. And that's something from a policy setting standpoint that we're only just now able to do. So it's really kind of remarkable to see this. I'm going to give you the last word, Dan, of the things that you want, either words of warning or words of encouragement you want us to think about going forward with these kinds of models.
No, I just, one of the things that I think that we're seeing more of kind of just in the network world is that there are larger data collection efforts that are using more networks. And so I think that if you kind of look at, social network analysis, particularly, a decade ago, right? Prosper was kind of unique, and certainly like its size. And I know that as someone who is seeing more and more papers that are published and I'm reviewing them, that they're collecting more network data from kind of similar school-based projects. So I think that this is going to be an area where we see more people thinking about it, because back when we started, and we started dealing with this question, the multi-group option in Siena did not exist. If you looked at the Siena manual, it didn't mention meta-analysis. And if you ask people, well, how do you deal with multiple networks? The structural zero approach was really kind of the default, because most people had small networks, and there hadn't at that point been too much thought into how do you deal with this. And now if you look at the manual, you're going to see they offer like 3 or 4 options, and they walk through some of the ways that you can do this. And my guess is that that is going to continue, and that as people collect information, particularly from different settings, that people will spend more time kind of trying to think through the best way to set up these models and understand kind of their strengths and limitations.
Awesome. Thank you so much, Dan. Appreciate it. And for those that are interested in these questions, there's a Dan McFarland, Multidone, and I are guest editing an issue of the journal Social Networks on ecological networks, and by there we mean social ecology. And the main idea is that by doing these multi-level models around networks, you can think about sort of higher level selection effects and setting feature effects affecting the local level network thing. So, and I've been amazed seeing the papers that have been coming in at the wide variety of the kinds of data that are available of these sorts. So this really is an area that's just going to just keep blossoming, I think, over the next 10 years. All right, on our schedule, we have a 5-minute break while John gets set up to talk about missing data in network analysis. So I'm going to give a hand to Dan. Please do check out his presentation if you haven't had a chance to yet. I suspect he would be amenable to an email if you find yourself analyzing these kinds of data and get lost. Just send him a note.
Of course. Thanks, everyone.
Thanks, folks.